Hey everybody, here's part 2. So why did we learn about the GCF? Well, we're going to use that to both multiply and factor and then eventually solve quadratics, factoring out the GCF. All right, so first let's kind of review where factoring comes from. It's kind of the opposite of multiplying. Remember how to distribute? That's like a form of multiplying. So we're going to practice that for a little bit, and then we're also going to practice factoring. Again, you could call this distribute or distributing, but we're going to multiply that A through A times B and then A times C. The opposite of that would be factoring. And so here we're going to factor. And what I'm looking for is that GCF, that greatest common factor, and I can see that A is a factor of both terms. So I'm going to put that in front of the parentheses. So I'm going to make it look like what I started with over there. A times what is that first term, A times B. A times what is the next term, A times C. So after you factor out that GCF, you're thinking, what would you multiply that by to get that next term? All right, so we're going to practice. We're going to distribute the 3 through. And, really at this point, you could stop the video and actually do problems 5 through 11 on your own and try them and then restart the video and check your work. Let's see, 2t squared minus 8t. So distributing that 2t all the way through. And this one will be 6x squared plus, oops, I almost wrote 7. Let's try that again, 21x. And now we're going to do the opposite of that. We're going to factor. So for these, you're looking for the GCF. What number would be the largest number that would divide into both terms? And I think here we just have a 2. So I'll factor out a 2, leaving me with a 3a and a 10. And I'm again thinking, what would I multiply the 2 by to get the term up above? And so a way to check your work to see if you have factored correctly is to do the reverse, multiply it out and see if you get the original problem. And sometimes that's easier for us to multiply through and check back. So you can always do that. All right, for number 9, I have, let's see, 2 would be a common factor, not 4, or 3 would, right? Let's see, 4, and I think also 6. I think 6 is my GCF for this one. So I'll factor out a 6. That'll leave me with 4x squared and 3. All right, number 10. This one has an x in both terms, so I'm going to factor that out. And then the last one, I keep forgetting my little equal signs there. And the last one looks like I have a 2x that I can factor out. And that'll leave me with x plus 12. So again, this is somewhat a little bit of a review of Algebra 1, hopefully for you, and it's kind of the foundational stuff that you need for the next step. And this is kind of our aha moment, like what we've been working towards. So again, we had this problem. How do we isolate the x? There wasn't really an easy answer for that. But now with greatest common factor, what we can do is we can factor that problem. We're going to combine that with this idea. If you notice here, these are equal to 0. This one, I'll explain how we get that equal to 0. But for now, I'm not going to explain too much why they're equal to 0, but it is an important piece to this unit. But for now, the fact that they're equal to 0 is really important because of the zero product property rule, which basically says if you have two things multiplied together and the answer is 0, one of those things must be 0. Right? So if A times B is 0, either A is 0, B is 0, or maybe both of them are 0. So we're going to use that idea to solve for x. If this is equal to 0, I'm going to solve for what value of x would make it 0. First, I have to factor into two different numbers so that I can figure out which one is which. I'm going to factor out a 3x, leaving me with x plus 4 equal to 0. And again, I have two things multiplied together, the 3x, and I also have the x plus 4. If two things multiplied together is 0, one of those must be 0. So now I'm going to solve for x and see what would make it 0. So I'm going to set each of those factors equal to 0 and solve. Divide by 3, x equals 0, subtract 4, x equals -4. At this point, you have a couple choices of how you want to write your answer. You can stick an or in the middle of that and you're done. X is equal to 0 or x is equal to -4. You could use the notation that we learned in the last unit and list the possible solutions like that. So that's an option as well. All right, for number 13, looks like a 3 and an x would factor out, leaving me with a 2x and a 5. All right, again, like the first one, set each of the factors equal to 0 and then solved for x and see what would make that 0. Divide both sides by 3, subtract 5, and if you notice here, look what's going to happen. I'm going to get a fraction, and that's fine. Just leave it that way. You don't need to do anything else. Once it's already like that, just, it's less work. Just leave it that way. So x is equal to 0 or -5/2. And for the last one, so as I was saying, that one isn't equal to 0. So what would you do? Would you try to do it like we did in lesson 1? If you did that, if you're trying to eventually take the square root of both sides, you divide by 4 and you'd have x squared. Don't write this down, by the way. I'm just showing you how not to do it right now. And now this would be 3x. Notice if I go to take the square root, okay, yeah, I have x over here, but what do I have on the other side? I still have an x. I never isolated x. I never got it by itself. So this is not going to work for us. So we need to kind of maybe, think of something else. Well, I could subtract 12x from both sides, and now it will be equal to 0. 4x squared minus 12x is equal to 0. Now it looks like the other problem. So now I'm going to see if I have a GCF and set each factor equal to 0. I'm going to factor out a 4x and set each of those equal to 0. And we're almost done here. X equals 0, x equals 3. All right. Have a great day. See ya.